Welcome to academy.com. In electrical engineering, let us discuss about Ohm's law. Ohm's law states that voltage across a conductor is directly proportional to the current flowing through it, provided all physical conditions and temperature remain constant. Here, Ohm's law states that voltage across a conductor V is directly proportional to the current I. We know that the direct proportion changes if you introduce a constant that is equal V equal Ri, where R is a direct proportional constant, which is the resistance of the conductor. So mathematically, this current voltage relationship is written as V equal to IR. Now look at this triangle. It is easy to understand the formula. Suppose we want V is I into R. If you want I, V over R. If you want R, V over I. Look at these small examples. If the resistance of an electric iron is 60 ohms and a current is 4 amps flow through it, the conductor resistance, find the voltage between the points. Here we want V. Voltage V equal to formula IR, which is I is given as 4 amps, resistance is 60 ohm, which is equal to 240 volts. Therefore, the voltage across the conductor is 240 volts. Next question, an EMF source of 10 volts, voltage is given 10 volt, is connected to purely resistive electrical appliances like a light bulb. An electric current of 2 amps flows through it. Consider the conducting wires to be resistance free. Calculate the resistance offered by the electrical appliances. Here voltage is 10 and current is 2. Therefore, we know the formula V equal IR. We need to calculate the resistance. R equal V over I. V is 10 volt, I is ampere, I is 2 amps, that is 5 ohm. Resistance through the wire is 5. Resistance through the source is 5 ohm. Here, calculating electrical power by using Ohm's law. The rate at which energy is converted from electrical energy of the moving charges to some other form of energy like mechanical energy, heat energy, energy stored in magnetic field or electric field is known as electric power. Power is actually energy converted is a power within the time, within the particular time, that is a per second. Energy per second is a power. The unit of power is watt. The electrical power can be calculated using Ohm's law and by substituting the values of voltage, current and resistances. Look at this formula, P equal to VI, power equal voltage into current. Power equal V square over R. That means here we have to substitute I value equal to I is that was V equal to IR. From this I equal to V over R, that here substitute I is V over R, then equal to V squared by R. Then when the current and resistance are given, here suppose P equal to VI, current is given, we have to substitute voltage, voltage equal to V equal to IR. We have to substitute the IR value here, that is P equal to P equal IR is V, therefore I squared R. Therefore I squared R is P. Now power triangle, that is P equal to VI. Then suppose we want I equal to P over V, V want is P over I. The power triangle can be employed to determine the value of electric power, voltage and a current when the values of other two parameters are given. That means V and I is given means power is Vi. If I you want means P over I, V want means P over I. Here I equal to P over V equal to P over I. Like simple cases you can find. Ohm's law pie chart. To better understand the relationship between various parameters, we can take all the equations used to find the voltage, current, resistance and power, and condense them into a simple Ohm's law pie chart as shown in figure. Here, look at this, it's a very useful pie chart. Suppose we want P, we can use Vi or I squared R or V squared over R. Suppose resistance you want means P over I squared. That means look at here, P equal to I squared into R. If you divide I squared, then we can get it R. Like V squared over P, V over I for the resistance formula. Suppose volt formula is, we know that IR or P over I or square root of P into R. Then I is P over R square root V over V over R. Like this Ohm's law and power law, that is V equal to IR and P equal to VI, both combined together to make a pie chart. Very useful results condensed in pie chart. That means we can remember as it is, or we can derive one formula with other parameters given. Here next, Ohm's law applications. The main applications of Ohm's law are to determine the voltage, resistance or current of an electric circuit. That is, Ohm's law is useful. Ohm's law maintains the desired voltage drop across the electronic component. Ohm's law is also used in DC ammeter and other DC shunts to divert the current direction. Limitation of Ohm's law. Following are the limitation of Ohm's law. Ohm's law is not applicable for unilateral electrical elements like diodes and transistors of electronics equipment, as they allow the current to flow through in one direction only. For nonlinear electrical elements with the parameters like capacitance, resistance and etc., the ratio of voltage and current won't be a constant, linear constant. It won't be a linear relation with respect to time, making it difficult to use Ohm's law here directly. Next, resistance here. Next, in Ohm's law details we'll do in next videos. Look at here. Here so far we discussed about Ohm's law detailedly and its formula, and power formula and its pie chart method. This is very useful result we have done. Please subscribe our YouTube channel.